Okay, everybody. Many people will have to watch this first part later online, should there be any further interruptions. Okay, quickly, let's see. Let's answer a few questions here. I'm just going to go as fast as I can. Please bear with me. I want to make sure I touch every section possible. Oh, let's start from here. Let's start from this one. Organic reactions. By now, if you followed me, you should know how I deal with my organic reactions. I do it in such a way that I don't even think anymore. Yeah, I just use my acronyms, and it just works for me. And what are my acronyms? Quickly. That's all I do, and it just works for me. Let me do this. So when it comes to organic reactions, what do I do? Organic reactions. This is all I do. So this is all I do when I look at, so my job will be to identify the compounds if they are saturated. All right, so what does my SSS stands for? If I'm starting from a saturated and I end up in another saturated, I am simply talking about what? A substitution reaction. You see I'm going to answer this question very fast. Saturated to unsaturated, what type of a reaction is that? Elimination. Please confirm that you still can hear me. And number 3, when I start from an unsaturated and I get to a saturated, I am simply going to be dealing with what? An addition reaction. Thank you. Look, this is, so you do this very simple. What's wrong? Yeah, anytime, if you have saturated to saturated, you're starting substitution. It's also substitution. Open. And then my last one simply says, if I have, anytime I use a concentrated acid or base, the E stands for elimination. And D stands for if I use a dilute acid or base, I am simply talking about what? Substitution. And every time I eliminate, you must know that I am using, for dilute, I am using mild heat. And for elimination, I am using what? Strong what? Heat. Strong heat for elimination and mild heat. If you can just keep to this, I promise you that 100% on organic reactions is mostly guaranteed. Saturated to saturated, you have a substitution reaction. Saturated to unsaturated, you have what? Elimination reaction. And the third one, unsaturated to saturated, you have what? An addition reaction. Your job is to now check what you are adding, what you are removing. If you are adding hydrogen, then it becomes what? Hydrogenation, you know. But the main thing is done here. Your job is to look at, okay, what is it that I'm adding? And when you get to a question like this, all you have to do is to identify what is saturated and what is not saturated, and the game is over. Done quickly, quickly, quickly. I'm waiting for those of you that are writing so we can quickly, please take a picture so we can. I need us to cover the whole section today. So you'll see how I use mine. Don't forget the CEDS, very important. Concentrated, you eliminate. Dilute, you substitute. But to eliminate, you also need what? Strong heat. And when it comes to dilute, you use what? Mild heat. Check how I'm going to do this question now. Look at this reaction. The flow diagram below shows how organic compounds can be prepared using what? Hexane. Now, what do I know about hexane? It is what? It's an alkane, right? Which means it is what? Saturated. Okay, so check what I'm going to do. What is this? Saturated. I am going to propene. All right, now this is very important. Okay, let me just go here before I go to the next thing. Let me do this. Let me add a small section to this. Cracking. Cracking means you are breaking down a large or a long hydrocarbon into simpler, usable units. Place definitions are your thing right now. You should be just flowing with them. But when you do a cracking, so we're going to have a large hydrocarbon. In most cases, it's an alkane. You are going to get, there are two options. You are going to get an alkene plus a small alkane, or you get an alkene plus an alkene plus hydrogen. These are the two options that you have. It's either an alkene or an alkane, or you have an alkene, alkene, and hydrogen. And your job will just be to balance the numbers. It's so easy. The number of carbons on the left should be the same number of carbons on the right. The number of hydrogens on the left should be the same number of hydrogens on the right. It is very, very, just count. This is the algebra of chemistry. Just count. So for X. Okay. So it does. If you say so. All right. Check what I have. I have but do you notice I have two compounds? Oh, so one compound breaking down into two. Ah, I see. What is this? This is what? An alkene. And I know it is what? Unsaturated. Can you tell me what compound A would be? It is very easy now. What is hexane? C3. You must know this. If this at this stage, sorry, C6. You must know this. I'm already thinking about prop. C6. It's hexane. 6 times 2, 12. Plus 2, 14. We cannot negotiate you not knowing that right now. Because alkanes have what? Cn, H2n, plus 2. Now we have a propene. Prop is what? 3. And one thing I check is, how many E's does this have? 2. I'm going to multiply my 3 by 2. I'm just playing game. What is this? C3H6. Oh, can we find compound A quickly? How many carbons do I have here? 6. I have already taken 3. How many do I have left? Really? Calculators. 6, 3. 14 minus 6. Done. Compound A is already done. What is my compound A? 3. It's what? It's an alkane. So it's what? Propane. Are we making sense there? Look, these are marks. I don't even know what the question is all about. I'm just playing around here. Okay. Check this. The first reaction 1 is called what? Cracking. Why? We are breaking a large hydrocarbon into smaller usable what? Units. Let's go for reaction 2. It starts with a U. There's only one thing that starts with a U here. Do you see how simple it is? There's only one that starts with what? A U. It is unsaturated. Where is it going to take us? Saturated. What type of reaction? Okay. automatically we are done with reaction 2. Reaction 2 is what? An addition what? Reaction. Can you see what we are adding? We are adding what? H2 to C3. Can we draw C3H6 just for you to see? 1, 2, 3. 1, 2, 3, 4, 5, 6. If you are lost, draw. Something is wrong. I need a double bond. But if I do this, something is now wrong again. Something is wrong, right? Carbon must always be 4. So, can I do that? And take this away. Propane. I am now adding what? H2. Oh, where will that go to? There are 2 empty things here. Make sense? So, do you notice that already, what type of a reaction is that? It's an addition reaction. And we are adding what? Hydrogen. So, it is called hydrogenation. Because we are adding what? Hydrogen. I want you to please learn this quickly as well. When it comes to hydrogenation, nickel acts as what? A catalyst. So for hydrogenation, we use catalyst and sunlight. Just take note of that condition. For hydrogenation, what do we use? We use a catalyst. Your catalyst will be nickel or platinum. And what? Sunlight. Please put that note down. Put that note down quickly. For hydrogenation, when it comes to hydrogenation, which is an addition reaction, all right, we use what? Platinum or nickel plus what? Sunlight. Here you must get your marks fast in the exam. Okay, so are we all okay with compound 3? Compound C? What is our compound C? Propane. Is it saturated or unsaturated? Oh, it's saturated. Sweet. Look at compound 4. Why do I keep numbering? Going down. What do we have? It's another what? Oh, saturated to saturated. What's your answer? It's a substitution reaction. We're done. And to make life easy, draw the structure. Can we draw 2-bromopropane? 2-bromopropane says prop, 3 carbon atoms. But bromo is sitting on carbon number 2. Can you see what we are substituting already? What are we substituting? We are removing this H and replacing it with what? Br. Oh, sorry. And guys, because it is substitution, what are my conditions? CEDS. Dilute acid or base, but we normally, in most cases, we use a strong base there. All right? And what? Mild heat. Oh, so let's write the condition. What do we need? Dilute. Give me an example of a strong base. Na. Okay, but in this case, let's see. Do you know that when you are doing substitution now, you must bring in, you are bringing in something that has what? A Br. I don't know if it's what I'm saying. Let me do this for you. Check this. So, guys, here, sometimes just try to think of what's going on and play your cards nicely. That's all you're doing. Check this. We want to go to what? This. Br. All right. Where we're going. You see where we're going, right? So what are you doing? You are going to remove this guy and replace it with this one. But if you are replacing, this guy won't just come and replace anyhow. What do we do? Check what I'm going to do. Please, I want you to take note of the dynamics. Just watch the dynamics. Now, you want to get rid of this H. And you want to what? Bring in what? It means you must be adding something to this. What can you add? You can add that. Br2. So your Br2, check, it's Br and Br. Do you see that this is going to take the place of that? And this would come back and take the place of this one. What are you going to have? Plus what? HBr. Do the math. Is that making sense? Do the math. You know you are going, guys, you don't just replace. Where is that one coming from? You must ask yourself that. If I were to use something like this, check this. If I were to use this here, what am I going to form? If I bring in any, do you see that our product has Br? But if you just use sodium hydroxide, is there any Br here? No. So keep an eye on where you are going. We call it stock taking. See where you are. See where you are going. Think of what to add. So in this case, if I'm adding sodium hydroxide, I'm not really helping myself. Where's the Br? It just appears, boom, from nowhere. No. Stock taking. Are we together? To your stock taking. So in this case, yes, I can use it as a catalyst, but the main thing would be what? To add what? Br. And when you add, do you see it's only one? It's 2-bromo. You remove this one for this. This one must also take the place of that. So you are left with what? HBr. Are we okay? All right? Now, check this one. What's happening here? D. The word D means to remove. So do you see you are starting from a saturated? Where are you going when you remove? Unsaturated. What are you removing? Hydrohalogen. One hydrogen and what? One halogen. Well, we are starting from what? 2-bromo-propane. Let's go and take our 2-bromo-propane. Let's draw. Guys, just enjoy. If you are lost, draw. And do mathematics. Okay. This is when we use what? Markovnikov's rule. All right? Using HBr. Okay. It could be marked correct. Let's listen. What if I use HBr? It's still okay. Because if you use HBr, just need to write it nicely. If you use HBr, so the Br, the place of that, and what are you going to have here? Plus what? H2. Okay? You're still correct. Now, let's do Markovnikov's. Isn't it? Sorry, Zaitsev is, Markovnikov is addition, Zaitsev is what? Remover. Now, what are we removing? Minus HBr. I'm just writing this there just to show us, right? Which one do you remove? First, you remove the Br. Now, the question is, which hydrogen do you remove? You go to the next one lying by the side of the Br, right? You choose the one that has what? The smaller number. But in this case, do you see there are 3 hydrogens here? There are 3 hydrogens here. Can remove anyone. So can I remove this one? What are we going to have? H, C, 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 H. What do we have here? H, H. We have removed this guy. Please don't remove the hydrogen. You won't be fair to remove both on one carbon. You're wicked. Don't be wicked. Okay. So I have removed that. But there's this H there. Which other H is still there? Is that correct? Something is wrong. What is wrong? We need a double bond, right? Where will my double bond be? Is it fine? Always count, guys. Make sure you count. When you draw, use a pencil. When you are done, you can ink it up. But even if you leave it as a pencil, it's still fine. So that when you make a mistake, you can quickly what? Erase. Are we okay? Okay, but hold on. This thing is still wrong. It's not okay, it's not wrong, but it's not complete. We removed HBr. Okay, hold on. If it is elimination, what do we need? What is my condition? Concentrated what? Base and what? Strong heat. Let's go see something. We need to write a complete one. So we have what? Strong what? Heat plus a base. NaOH. What do we write at the end of the day? So check. I am using NaOH to remove what? HBr. Let's break it down. Your Na becomes Na plus, OH minus. Your HBr becomes what? H plus, Br minus. Positive will attract what? Negative. Oh, so my Na will attract what? Br. And your H will attract what? OH. To give us what? Play your cards. Now, guys, this is just chess. You're playing games. Easy. All right. I think if you check, I have moved from the top down. Let's see the questions that follow. I'm done. I don't know if you see that we're done. Reaction 1, done. 2, done. 3, done. Type of molecular, done. State the function of nickel, catalyst, done. Structural formula to write the equation of reaction 3. Did we do that? Done. Write down the IUPAC name of E. Oh, let's write down the IUPAC name of that compound. What is this? 1, 2, 3. It is what? It's just propene. Prop 1 in is not really correct. They will accept it, but it's not correct. Why? You cannot have prop 2. Make sense? It's prop. If it's more than 3, then I can start changing number. I don't know if it makes sense. Because if I remove this one and bring it here, it is still on carbon number 1. Guys, I don't know if you enjoyed that flow. I don't know if you enjoyed the flow. Do you notice that everything I used was here? Everything. I have more questions at the end. I just want to make sure I touch every bit of the question. If we get another question, we'll come back to the same thing here. This answers your organic what? Reactions. Let's see if I have esterification. That's the other one. Oh, look at this one. I don't even know where this paper came from. I don't know whether someone sent it to me or what. But look, play the game. I want you to learn how to play the game in organic chemistry. Look at what I'm going to do. It says propyl what? Ethanoate. Please stop there. I know you have finished reading. Propyl ethanoate. You are done. No. Propyl ethanoate. What do you know about propyl ethanoate? It's an ester. Formed from two things. Formed from what? It is from check, prop. It is from propanol and what? Ethanoic acid. I normally use ACE to do this. ACE, millimole. Your flour. ACE. You know your ACE flour, right? You don't bake. It's child. ACE flour. Can you have sunflower? It's maize. No, they also have the one for baking. The one you know is for pap. No, guys. Ace is a brand. It's like saying Benz. There is Benz convertible. There is Benz. Come on, guys. Switch on. Only pap. So their company is only for pap. Go and Google it. You would say the one you buy is for pap. Come on, people. All right. Go check the stores. Do I look like ShopRite? All right. Focus. You are busy looking for Ace. Now, can you work with Ace, pap, maize, millimil, your choice, millimil, without water? Can you walk around this without water? No. So you need what? Pap plus water. I have simply done by saying alcohols will react with what? Carboxylic acid to form what? Esters and water. Done. Alcohol will react with what? Carboxylic acid to form esters and water. That's why immediately I saw propyl ethanoate. The first one is always your alcohol. Propanol. Ethanoate, ethanoic acid. So, check. I want you to see what we are enjoying here. Can be prepared from what? 1-bromopropane by a 2-step process. Oh, wait, hold on. We need something here. What do we need? We need concentrated what? Sulfuric what? Acid. Plus what? Strong heat. But the strong heat must be heated in a bowl. Why? Alcohol is flammable. You don't heat it over. We call it a water bath. Why is that possible? Why is that so? Alcohol is what? Flammable. Oh, my spelling. Just because I don't like it. I even don't know how to spell it. Alcohol is what? Flammable. It's a very good 1-mark point that you should know. Alcohol is what? The easiest way to down is a bar. You don't even need petrol. You just open one bottle, put fire there, and leave the place. You will be causing explosions. Pop, 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 pop. Huh? That's so cool, eh? Boring. You're not so. You should be adventurous. Okay, now, guys, check. I want you to check how I'm going to get my. I want us to study and just play with it. To play with it, you must know the first one. Propanol and what? Wait. Propanol. I already see something here. What am I seeing here? Do you see that? I have 1-bromopropane. Let's go write that. So it means from 1-bromopropane, I must get to what? Do you see? I must get to propanol. Then, in step 2, I am going to add my what? Does that make sense to you? Does that make sense? You got to know the basics, then play with it. So 1-bromopropane, it will get me to propanol. I add ethanoic. Make sense? All right. Let's check something. How do we move from here to here? 1-bromopropane, it's saturated. Alcohol can be considered as a saturated compound. Therefore, saturated to saturated, what do we have? Substitution. Okay, let's draw 1-bromopropane. 1, 2, 3, prop 3. 1, bromo. It means my bromine. Make sense? Just follow the names. All right? Make sure you write the hydrogens. Where are we going to? We're going to what? propan 1-ol. We should actually write that propan 1-ol because we could have propan 2 as well. Oh, what do you notice? It's going to be substitution. Do you see that, right? Now, I want you to see this. Please understand and enjoy the beauty. But this guy must come with something. It is substitution. Can we go back to our table? When we have substitution, what do? Check. It is what? Dilute base and what? I want you to see that everything I'm doing is right here. Dilute what? Base. Okay. And what type of base? It must be a strong what? Base. So you could use dilute sodium hydroxide, or you could use that. Anyone is fine. And what other condition? Mild what? Heat. But check something. Something is now wrong. Yes? All right. We are going to remove BR. Is that okay? What are we going to produce? If you use any of the two, let's say Na, you have Na and what? OH minus. This OH minus comes here and takes that place. What happens to the BR? It must come and replace this guy. So at the end of the day, what do you have? NaBr. If you use KOH, what are you going to have at the end of the day? Plus what? KBr. What type of a reaction is this? It is what? Substitution. Saturated will give us what? Substitution. And if it's substitution, you know it's dilute strong base and mild heat. Okay. What else? Oh, where were we? Here. Oh, but check what the examiner says. Use what? Condensed. See, that condensed is not so easy. All right? That condensed is not so easy. Start from structures. Then go to what? Condensed. Let's draw the condensed. What's the first one? CH2Br. What's the next one? In the middle. CH2. You get that, right? What's the next one? CH2 plus. Oh, 3. Na. Oh, you must write the whole thing. And this is your inorganic reactant. They normally ask sometimes. It's not an organic compound. Leslie, I hope you're answered. That's the inorganic what? Reactant. Sometimes they do ask, write down the formula. What are we going to have? Give me the formula. CH2OH. What's next? CH2. What's next? CH3. Plus what? And this is known as the inorganic product. So take note of those names. Inorganic reactants. Guys, if you are confused, just play games and draw your structures. Play around with it. See where you're starting from. See where you are going. You would know what happens in the middle. All right. So that one is done. Write down the IUPAC name of A. Oh, this one is wrong. It's propan 1-ol. Because it's possible to have propan 2, right? Propan 1 what? Ol. Are we okay? When you are doing esterification, please use primary alcohols. Propan 1, butane 1, butane 1, anything, just 1, 1, 1. Step 2 takes this. In step 2, compound A, I think we are done with all of this. What type of reaction takes place? Esterification. But I want to show you something here. Write down the structural formula. Oh, one condition. I think we already spoke about the condition, right? In the presence of what? Concentrated what? Sulfuric acid and what? Strong what? Heat. I want to give you 5 marks. 5 marks, quickly. All right. I want to give you 5 marks here. In this question, they said 2. But I want to make it 5. And what do I mean by 5? Use structural formula to represent the whole thing. It's 5 marks. Are we okay? But just a section will give us 2 here, but I want to draw the whole thing. What are we saying? Propan 1-ol plus ethanoic acid. Okay? Let's draw the whole thing. It's propan 1-ol plus what? Ethanoic what? Acid to give us what? Propyl ethanoate. Let's quickly draw. Oh, and water. And water. That's how we say it in the UK. Water. Yeah, we take water from the bottle and put it in the kettle so you can drink it. Okay. All right. Propan 1-ol. 1, 2. Please, I want you to follow these 5 marks. Easy 5 marks. Don't put your OH on the left. Put it on the right. You have that. In fact, if you want to do it nicely, just show that. Ooh, then you are good. It's nice. Ethanoic S. How many carbon atoms? 2. You must know all of those. If you don't know that by now, I don't know how to help you anymore. Ethanoic 1, 2. Again, your functional group. Draw it COOH. OOH. Do you see that? 2 carbon atoms. We have that. Check what we are going to form. Let me bring it down here. I am going to form water. The question is, where is my water coming from? Make sense? Check what I'm going to do, guys. I know you cannot do this in an exam, but it's a smart board. I want you to see what I'm doing. Make sense? Because I have cut out that first part. Let's come here. And that's my ester. Because I have extracted that water. Is it making sense to you, though? I wanted you to see that and see the extraction. So I am done there. Plus my what? H2O. Please be careful with the structure of water. That's how it's supposed to be drawn. 5 marks. Like which way? It's fine. As long as they are bent. This, you get a 0. VSPER, grade 11. Electronic distribution of, what's that? Please just draw that. Okay. Today I don't have energy for explanation. Just draw. Guys, you get 5 marks. I don't know if this makes sense. Are we okay? 5 marks here. Bonga, are you okay? Huh? 5 marks. But which one did they want in this exam, in this question? The only thing they wanted was this one. Is that okay? That was what they wanted. Do you know how to name esters? Oh, other organic reactant. Okay. All right. Whatever. Okay. All right. Do you know how to name ester? So they wanted this one, right? In the question. But it's important that we are able to draw the whole thing. It's 5 marks. You get 1 for each of the compounds and for it balanced. Can we name this ester? To name this ester, you know what I normally do? I break my ester into 2. That orange, that O, I see it as a ring that connects them, so I separate them. It's a divorce. Is that okay? And I know it is made up of alcohol and carboxylic. Carboxylic is where your double bond is. So that's my carboxylic side. Oh, then I'm done. Then this one becomes what? This is the alcohol, becomes propyl. And 2 there gives me what? Ether. No, wait. By the way, in the presence of what? It doesn't really matter, but it's one name though. But, okay. Please, that was just a crash course on organic reactions. But do you notice your key was on SSS, SUE, USA, CEDS. And when it comes to addition reaction, what do you use? Nickel or platinum in the presence of sunlight. All your reactions in place. We're done. And for esterification, you have sulfuric what? Acid. Oh, all right. There's an acid. So it's just mixed. As some of you are sending me, I was just putting the questions there. So just bear with me. It's not in order. Here is acid and base. Oh, didn't we do this? No, we didn't. Okay. Ammonium hydroxide is a weak base. What is a weak base? A base partially what? Dissociates. You are already wrong. When you say dissociates to form, lies. Dissociate in water. If you don't put water, 0. Water is powerful. You think you just drink it and that? No. Because you must mention where it is dissociating. Okay? In water. Please. Okay? Dissociate in water to form what? A low concentration of hydroxide what? Ions. Please, definitions right now. All right. Do you want to get me those 3 marks? We did pH yesterday. Please, quickly, get me those 3 marks. Fast. Ammonium hydroxide solution. Ammonium hydroxide solution has a pH of 10,09. Calculate please read very well. Calculate the concentration of what? The hydronium what? Ions. I gave you a formula yesterday. We should be done. 3 marks for free. What's the formula I gave you yesterday? Concentration of what? Hydronium ions equals to what? 10 to the power negative what? pH. Examiner says hydronium what? Ions. And what would this give us? 10 to the power negative what? 10,09. What's your answer? 8. 8,13 moles per. Remember that for us to get pH, what do we go? pH is negative log, whether it's an acid or a base. pH is negative log hydronium what? Ion. Now, if they ask me to calculate the concentration of the hydroxide ions, and I go from here, I go to my kW of water. Please get the difference. They said pH, look, there's only one formula for pH that should ring in your head at the moment. Negative log of what? Hydronium ion, and that's what they want us to calculate. But that is if I'm looking for. So I would use this. If the examiner had said, okay, let's do it. Let's do it. If the pH is 10,09, let's calculate the concentration. Check here. Let's calculate the concentration of the hydroxide what? Ions. So if I want this, what do? There are two ways. I know pH as what? 10,09. What is pOH? pH plus pOH equals to what? You remember that? Do I know my pH? 10,09 plus pOH equals to what? Please read very well. When you calculate, be in sync with your calculation. What's my answer? 3, don't lie, Jube. 3,91. That's my pOH. But what am I looking for? So what do I know? Oh, concentration. Check this. Check this. If it makes sense to you. 10 to the power negative what? pOH. Do you see the same formula? Make sense? No. I am working from pH. So what would that give me? 10 to the power negative what? 3,91. Guys, it is the same formula we are manipulating over and over again. Just not if it's for pOH, we're talking about OH. What is J on 4 here? 1,23 times 10 to the power. Don't forget your unit. Please, I hope it makes sense, guys. You see, the issue is sometimes we assume what the examiner is asking. So, they gave me pH, so definitely I'm looking. No. Read the question. Are we okay? Or you can from here, KW. So you can from there say, Biggie, I'll respond to you now. From here, you already know this. So you can substitute into what? KW, which says what? Hydronium ion concentration equals to 1 times 10 to the power negative what? 14. Do I know this? 8,31. Oh, so what do I have? 1 times 10 to the power negative 14 over what? 8,31. Do you want us to confirm the answer? Somebody confirm. Is it the same thing? Thank you. Choose your method that works for you. Guys, are we okay? Are we okay? Are we okay? We okay? Guys at home, please talk to me before I go on to 7.1.3. Talk to me. Are we okay? Huh? Please confirm for me. Just a confirmation. That's where the mistake, 3-1 and 1-3. All right. Okay, good. 7.1.3. Will the pH of ammonium chloride solution be... Guys, by now you should know ammonium chloride. You must have seen this in questions. Ammonium chloride, check. NH4Cl. Ammonium chloride comes from ammonia and what? HCl. Ammonia is a weak what? Base. And HCl is what? This is a common compound they use in your acid and base if you have been going through questions. And please understand that it is going to be, this is a strong acid. What is this? It's an acidic what? Salt. Means the pH is what? That, if you have been practicing, you must have seen that over. And you don't even need to think at the moment right now. 7.1.4. How do we deal with that? It goes back to your definition, guys. An acid is a substance that produces what? Hydronium ions. When ionized in, not solution, in what? What was that defining? What was I defining, Vicky? Was that defining? An acid is a substance that produces what? Hydronium ions. When ionized in, okay, I apologize. Good. Because you came on attacking me. All right. Okay. Explain. Now, this is what I want you to see. Acidic salt. It's an acid. Use that definition to guide yourself. If it's an acidic salt and I add water, do you know what this is called? Hydrolysis. Salt with. But guys, this is an acid. What must be formed? Hydronium ions. I don't know if I'm making sense. Let's define an acid. An acid is a substance that forms what? Hydronium ions when ionized in water. So we have already said this salt is what? Acidic. It means if it ionizes in water, one of the products must be what? Hydronium ions. Does that make sense? So, for me, this is what I would tell you to do. Break this down into what? NH3 plus what? HCl. Do you see that? Plus what? Water. What will this reaction then give you? That's the acid. What would you get? Plus what? I don't know if it makes sense. And now, do you see we have ammonia here? And we have ammonia here. It's called a spectator ion. It's fine. If you didn't break it up, this is just to show you how to get to it. If you didn't break it down, there's no stress, my child. You just write what? My troublesome one. H3O plus what? Cl minus, and you can still show the ammonia. There's nothing wrong with that. Okay, if you have NH3 Cl minus, okay, it's still okay. No. You cannot have NH3 Cl minus. Nah. Nope. There's nothing like NH3 Cl minus. It's NH4. Okay, but just write it like this. Keep safe. Okay? You get your 3 marks here. 1 mark on the left, 1 mark on the right, and... But let's see. Yeah, you can, because what you are basically saying is you are combining this. All right, it's okay. But just break it down like this. And what you need to remember is, if it's an acid, it must form what? That's my guide. If it's a base, it must form OH minus. So extract OH minus and deal with all the legalities of the other ones. the shenanigans. It's balanced already, my child. It's balanced. Okay. Sweet. Let's get some 8 marks here, guys, quickly. Let's get some 8 marks. So, I want to cover this whole thing so that you can watch it again at night. You wake up and go through it again, the whole session. A 2.5 grams in pure sample of zinc is added to, okay? Please don't be afraid. Some of you are already looking at these 8 marks and say, oh, not me. Let me try to get the 3 marks. The 8 marks. No, come on. If you have followed my strategy of doing acid and base, I have 3 steps. It works perfectly. I have 3 steps of solving my stoichiometry. They will not give you the number of moles of what you want. They will give you number of moles of the other substance. Use that information to get number of moles, step 1. Step 2, mole ratio. Step 3, calculate what you want. Finally, you know what I'm talking about, right? Easy. Let's check. But we don't get excited and not read. That, oh, yes. Please. A 2.5 grams impure sample of zinc is added to 25 cm cube. Guys, I don't work with cm cube. I cancel immediately. 0, what? 0.25 dm cube of a 1 mole per dm cube sulfuric acid solution. All right, guys. Too many things. Stop. Extract information. What do we know? The mass of zinc is what? 2.5. Is added to what? Volume 0.025, right? What's the concentration? 1. Of which compound, by the way? Okay. And I'm going to give you another tip today. On completion of the reaction, the excess, please don't think they mistakenly did cap locks. It's not by mistake. They're telling you something there. All right? The excess sulfuric acid is what? Neutralized by 15 cm cube. Let me pause here, guys. Do you notice there are 2 reactions here? Is that okay? When you see this, in most cases, to solve this easily, start from reaction 2 and go up. But let's see. Examiner says, okay, let's see. So, are you aware that volume of reaction 1 plus the volume of reaction 2 should actually be equal to 25 cm cube? That's the first information I wanted to know. Let's go back. It says zinc was dissolved in 25 cm cube. Then the excess was used. It means in reaction 1, we did not use all the 25. Make sense? Did that make sense? We did not use all the 25. What was remaining is called what? Excess. That's the excess we took to what? Reaction number 2. Are we good? Which one? Volume of R1 plus the volume of R2 is 25. All right. But it's not half-half. We just know that both of them would give us what? 25. All right, let's see. What do we do? So in this case, this is reaction number what? 2. But what did we use in reaction number 2? It was what was remaining. Calculate the number of moles of sulfuric acid that was in. Oh, they are simply telling us to get the number of moles here. Does that make sense? They will not give you the number of moles of what you want. They'll give you information on the second one. Can you tell me the information we have on sodium hydroxide? What do we have? 15 cm cube and 0.5 moles per. All right, let's quickly walk through. So I know for this. Guys, look, when it comes to acid and base, let your presentation be on point. I'm working with this. What's my concentration again? Anybody remember? 0,015, yeah? What is the concentration? 0,5. Biggie, you're not following. Number of moles of which compound? Sodium. This is what I did. I'm being specific now. What's your formula? CV. What is this? 0,5 times 0,015. What's your answer? Huh? Moles of which compound? But is this what I'm looking for? No. How do I get the number of moles here? How do I convert this number of moles to that? Mole ratio. No, you use the compounds that you have. In this thing, I know nothing about the sodium sulfate. I know nothing about water. There's no information there. What? If you did what? Yeah. Okay, what would you do from the... I'll tell you something. That zinc is impure. And impure substances don't react. So I don't know what reacted from that zinc. That's why I said when they give you two reactions, start from 2 and work back up. In most cases. All right. Do you notice yesterday the one we did with the 2 base? We started from 2 and then worked back up again. All right. So, can you see my ratio? What's my ratio? NaOH and what? H. Is it H2SO4 HCl? H2SO4, sulfuric acid. What is the ratio? 2 to 1. But what do I know? Number of moles of. So, guys, if you do your presentation nicely, you actually enjoy your work. What do I have here? 0,0075, and I don't know N here. What do we do? Cha-cha, cross multiply, pirate. What's our answer? 3,75 times 10 to the power? Moles. And we are done with the first part. Easy stuff. Please, those of you at home, talk to me quickly. Thank you, Leslie. Are we okay? What's the question? Because I don't know anything about the product. I don't know the volt. That's why your information is always important. Write out what you are given. And if you check my 3 steps, I always say calculate the number of moles where you have more info. Then use mole ratio. So you check where you have information. I know nothing about Na2SO4. I know nothing about water. And zinc is impure. Mufti, what's up? Where did I get the 2 from? Zintle. It's a mole ratio. Mole ratio. 2 and 1. So, Zintle, lovely question. Pull again first. Keep it down. All right. Now, calculate what? Percentage impurity. Impurity. That's how we say it in the UK. Impurity. Impurity. Percentage purity plus percentage impurity is equal to 100%. Uh-huh. Yeah. Do I what? All right, guys, let's check the formula. What is our formula for percentage purity? Very important. It is the mass of pure over total impure sample All right, guys, here's the formula. Now, let's check something quickly. I want you to see the progress of this. Do we know the total sample of impure? A 2.5 grams impure. So, we know this as what? 2.5. I want you to get the system quickly. What do I need? I need this guy. Right? How do I get mass? Number of moles of zinc should be equal to what? Mass over molar mass. Are you getting my... So, draw your flow chart as well. What do I need? If I can get this mass, I'll bring it here and then I'll calculate. But for me to get this mass, what do I need? Number of moles. What are my 3 steps? Remember reaction 1. Reaction 1. I told you they will not give you number of moles here. What will they give you? They'll give you information around here. What are you going to look for? The number of moles. Then use mole ratio to get number of moles. Get that number of moles, you get your mass. And do you see the link? So the question is, how do we get the number of moles in reaction number 1? Let's go back to the original. Guys, I want you to get this. In reaction 1, okay, let's see. What do we know about H2SO4? Talk to me. What was the total volume? Total volume is what? 0.025. Do you remember? Do we know the concentration here? No. 1 mole per dm what? Now, guys, this is the original. I want you to get this. This is the original that we had. Are we okay? But this thing was splitted into 2 reactions. Reaction 1 and in reaction 2, we're talking about the excess from reaction 1. We got something earlier on. What did we get? We got the number of moles in excess. What is it? 3.75 times 10 to the power. Oh, I want you to see if you understand this thing. If I add the number of moles in excess plus the number of moles in reaction 1, I should get the original number of moles. Let's do it again. I said number of moles in original should be equal to number of moles in reaction 1 plus number of moles in... I don't know if this makes sense. Make sense? Wait, do we know the number of moles in reaction 2 already? Yes, we do. But do we know the number of moles in the original? No, we don't. Can we get it though? What's the formula for number of moles? C times V. Original will be equal to what? N of reaction 1 plus 3.75. I don't know if this method works for you. What is my concentration and my volume? 0.025 times 1. We okay? Equals to number of moles of reaction 1 plus... Guys, you just need to understand the dynamics of acid and base. Do you think I can get the number of moles in reaction 1 now? Yes, I can. What is your answer? Do the math for me. 1 comma? Can we please confirm that? Number of moles in reaction 1. Let's confirm. Let's do the maths. Everybody do the math. 0.025 minus 0,02 moles of what? Sulfuric. Now, this is the number of moles in reaction number 1. Do you know why we needed that? We are now here. Make sense? Can I use my mole ratio? Let's go back to the question. Is it 1 to 1? Yeah, but 1 to 1. Please write your mole ratio. Zinc and what? Sulfuric acid. Do we know the number of moles here? Cross multiply. What is this? Moles of what? Zinc. Can we calculate the number of can we calculate the mass of zinc that reacted? Zinc is what? 60? 65 or 63,5? 60? 65. You sure? Juanele, you sure? Okay, what's your answer? Cross multiply. 130, 13,1 or something there. Huh? 13. You sure? 13. 1,3. Guys, our original is 2,5. Oh, it's me. Sorry. Thank you, Bibi. All right, guys, your mass must not be greater than the original mass. Do you know what this means? Because we are using mole ratio, anytime you're using mole ratio, you're using what reacted. Is that okay? Let me do something for you. We are saying 1,3 grams reacted out of what? 2,5. So what is the mass of your impurities? If 1,3 is pure, because only pure substances will what? React. So what is the mass of impurity? Mass of impurity would be what? 2,5 minus 1,3. What's your answer? Oh, so percentage what? That's what the examiner wants us to find. Will be mass of, guys, I want you to see the difference in the formulas. I'm using percentage what? Impurity. So I'm talking about mass of impure over total what? Sample multiplied by 100. 1,2, 2,5 times 100. What do you have? Close to 50. 40? Are you sure? 48. Check again. You should be having 45. $48. Oh, wait. Just 48. Something is wrong somewhere. What is the percentage impurity? What is the percentage purity? Which one is pure? 1,3 over what? Give me your answer here. 50? Okay, wait, guys. Something is wrong somewhere. Let's go back here and please recheck that number of moles that reacted for me. Okay, where's my calculator? Since I have mine. Don't trust you all. I've got trust issues. 0,025 minus 3,75 times 10 to the power negative 3. Please, I am not done, guys. I am not done with the calculation. Why are you giving me 0,02? Guys, we don't round off in the middle of a calculation. You would see that this little change, check where our answer would go to. It's 0,02125. 02125. 02125. 5. Please and please. What is this answer going to be? Do you see how it changed? 1 comma 3. You are rounding off again, Biggie. Please, guys. Biggie, I don't understand why you're getting a straight answer when we're using decimals. One comma 38 125. So what do we have? 1 comma 38 125. What would this be? 1 1. So 1 comma 11875 over 2 comma 5. What would that give us? I want you to see what we have done, the error that we committed. Check. 44. You were 4% off. 44 comma. Do you see the effect of running off? We're very far by 4%. You got what? And here, if we're looking for percentage purity, it is 1 comma what? Over. And basically, that will be me subtracting 100. This one from 100. 55 comma what? Because this and this should give me what? Please, let's learn. We don't round off. Do you see, just by rounding off, we're how many percent off? 4%. It's too big. It's too big. That's why there's an answer button on your calculator. Use that answer button all the time. Are we okay? Please don't let's round off. All right. We have some 20 minutes before break. Because some people thought we were not going to have break. People like Leslie. She sent me a message. Oh, that break would never happen. She is wrong, followed by you. Okay, we did this yesterday, right? We did all of this yesterday. Okay, this we didn't do. Let's answer this. 8 marks. We didn't. We just explained the DC. And what did we say? This was where this was where you didn't know which cell this was. This is electrolytic. Why? Because of the power source. And we said it is non-what? Spontaneous. Why do we use a DC? To maintain what? Polarity of electrodes. To maintain polarity of what? Electrodes. And we said electrical energy is converted to chemical energy. Please, it is important for you to know while we use DC. Another keyword here is this. APE. The anode is what? Positive in the electrolytic cell. Very important. Is that okay? The anode is positive. Okay, and what happens at the anode? Oxidation. Okay, guys, look, I want us to quickly, I want you to learn how to answer this question very, very swiftly and fast. Here, I want you to be smart. Is that okay? Be very smart. What is electrolysis? All right, electrolysis, you can actually also say that it is the conversion of electrical energy to chemical energy. Dan, use your energy conversions to define. Do you see it electrical to? So it's a process of converting electrical to Chemical. So there are about 3 definitions that are accepted, but that's very simple. I wanted to check something here. This is what I wanted to see. Guys, when I say chlorine gas, what is the formula of chlorine gas? Cl2. But do you know where it came from? It came from what? 2Cl minus. Oxidation. This is the formula from the table. This is your key. This thing is negative. Where will it go to? Is it the positive electrode or the negative electrode? Positive what? Electrode. I'm going to answer your confusion now. Or you're sorted. Okay. So it is this is negative, right? Do you see where we formed chlorine gas? Oh, chlorine gas was formed here. It means the chloride ions came to this side. This side must be what? Do you see the system? Chlorine gas is negative. Chlorine gas came from what? Chloride what? Ions. Chloride ions are negative. So they are attracted towards the positive. Easy. Make sense? How do you know a gas is formed? By bubbles. You almost said what? No. Examiner will tell you bubbles are seen. So you must know. Or they tell you what would you observe? You'll observe bubbles. If you check that video again, the last part of one of my videos, just by the electrode, you would see some small bubbles at the end. Okay. Are we done? Have we answered this one? Which one is positive? P. Write down the half reaction that takes place at P. Make sense? Now, an examiner will ask you, there's a question they normally ask here. Explain why sodium ions are not reduced. This is the question. Explain why sodium ions are not what? Reduced at the cathode. Very simple. Answer. Water is a stronger oxidizing agent than sodium ions. Therefore, they are reduced. Water is if you go and check your table, you'll find what I'm saying there. Water is a stronger oxidizing agent. I remember showing you how to use your formulas. Formula page. How to use your formula page to define. Okay, let me get a table quickly for you and show you. I have a table somewhere. You use the water of, what's the value? I don't remember the value. Don't let me lie to you. Vatel. Negative 0.83. This. All right, which other water? Let me quickly discredit all the waters. Okay, let me answer all your other waters. 1 comma? Sweet. It's not water. How do I know? Because it's not water. It is H2O2. It's hydrogen peroxide. All right, so the water we use is negative what? H2O2. All right, so guys, listen. Let's quickly. I want us to quickly answer a few questions that the examiner can ask you there. Oh no, network. Just a second. Let me check this at home. Oh. Network. Let's hope it comes back quickly. Let me try the other network. All right, let me just answer this question. They'll watch the recording, then we shut down and take our break, and then we come back. Okay, they'll do so that I don't disturb this recording. What was I saying? I think there's a question that the examiner would ask here, right? What do we have? H2O plus that. Let's write the half reaction at the anode or at the cathode. Oh, this is your question. Okay. Check this, guys. We have at the cathode, water is going to be what? Reduced. 2H2O plus 2E to give us what? Hydrogen gas plus what? Now, what do we have at the anode? We got what? 2Cl minus to give us what? Cl2 plus what? Plus 2E. Now, do you notice my electrons are balanced? 2E, 2E. What do? We write what's on the left to the left and what's on the right to the right because your electrons are now balanced. They would cancel out. So what do we have? 2H2O plus what? 2Cl minus to give us what? H2 plus what? All right. Do you notice that we are forming a base there? We are forming a gas. Where is this gas formed? This gas is formed at its reduction. At the what? At the cathode. This one is formed at the anode. And this is in the solution. But, okay, we're back online. We'll take our break immediately when I'm done with this. Or we can do that electrolytic question, then we take a break. But exactly past, we're taking a break. So that people who thought, I don't know how to keep time, will be defeated today. All right, so do you notice is the solution around the anode? It is basic. So an examiner can bring in acid and base here. Name the base that is formed around the anode. It is what? Sodium hydroxide. Remember, this was sodium chloride before. Now the Na is combining with OH to form what? Sodium hydroxide. And what is this called? This is called the net ionic what? Equation. Guys, there's no cell notation here. It's an electrolytic cell. All right. It's an electrolytic what? Cell. I have one more question before we then take a break. Oh, it's 14. So I can do this in 15 minutes. 11 marks. Come on, I wish this thing would just come back on. Let me try again. Just give me a moment. Let me see if I can get them back online. All right, guys. Sorry about that. It was network. Okay, I'll just quickly repeat what I said. All right, this was what I said. We wrote our half reactions. I'm sure we can all do this. And we wrote the net ionic what? Equation. And what I said was hydrogen gas is formed at the cathode. Chlorine gas is formed at the, use the signs. Opposite will what? Always what? Attract. And then OH is formed also at the anode. And we form a base. Sodium what? Hydroxide. I have one more question to answer. If you missed anything, you'll catch up because I'm going to post this lesson right immediately. Let's answer this in 10 minutes before we take our little break. Okay. Guys, it is an electrolytic what? Cell. Please take note. Anything that you want to electroplate, put it at the cathode. I normally say we see at C. Right? We see at C. Anything you want to electroplate. If I want to electroplate your head, I must put it where? At the cathode. Because I think I'm going to do that for Tess and to immortalize you. All right, check this. Now, do you see where my ring is? Where is my ring? My ring is going to be at the, already I know it's at the cathode. And the anode is what? Positive. Oh, it means this is what? Positive, and this is what? Negative. Define the term electrolyte. An ionic solution that conducts what? Electricity through the movement of ion. You need to write it in full. All right? Just sing the song. All right? That's what's playing in your, it's singing in your head. Okay. Now, I think I'm already done. Is the pure chromium metal the anode or the cathode of the cell? The pure one. It is the anode. Give a reason for your answer. Because that's where oxidation would what? Take place. Makes sense? Write down the half reaction that takes place at the ring. Guys, I want you to learn how to use your table. What do we have here? Cr3+. I want a solid to form here. So what's the solid? Cr. Because if you go to your table, there are different CRs there. Let's go to our table quickly and check. Look, I don't even need to go to the table. I can write it. It is Cr3+. It's reduction. What is reduction? The gain. It is going to be plus how many? 3E. To give me what? Cr. That is a solid. That is aqueous. 2 marks in the bag. All you need to remember, guys, is that what? Whatever you want to electroplate should be at the cathode. Let's find Cr. Good. Are we okay? Okay, let's do the last question there. Now, stoichiometry. Some 5 free marks here. Let's get these 5 free marks. Calculate the total charge transferred when the mass of pure chromium changes by what? 2 grams. Interesting. Let's start by writing the half reactions. We are looking for what? Total what? Charge. What is charge? Q. Electrostatics. Now, it means there are some formulas you must know because there's no electrostatic on your chemistry page. And you cannot ask them, please bring my paper of Friday. I want to, I need the formula page from Friday. You cannot do that. So, this formula must be at the back of your head. N equals to what? Q over what? QE. where Q is the quantity of charge. What is QE? The charge on what? An electron. And what is N? The number of what? Electrons. So it's a paper 1 formula that we're bringing into paper 2. All right. So calculate the total charge transferred when the mass of the pure chromium changes by what? 2. Do you know what that means? It means this one here, pure chromium, it's going to be minus what? 2 grams. Does that make sense? Why? The anode is dissolving into the solution. So it's becoming what? Remember, anode will always become what? Smaller. Make sense? All right. Let's write the half. Everything starts from your reaction. Do you know here, we are looking for Q, and Q has to be of what? Electrons. Let me show you my 3 steps again. That it's magical. At the anode, check this. At the anode, what do we know? It is Cr solid anode that is being oxidized to what? Cr3 plus what? 3 electrons. What are we looking for? We are looking for Q here. But what is Q? N equals to Q. They will not give you this N. They will give you information about the other substance. What do? Use the N there first. Use mole ratio to get. I don't know if you get what I'm saying. Which one? Number of moles. Number of moles. All right. So, guys, are you seeing my 3 steps? Let's check. They said this thing reduces by what? 2 grams. So the mass that reacted is what? Can we change this into number of moles quickly? Number of moles is mass over, everybody, periodic table. Those of you at home, quickly check as well. Taking a break now and returning at 7. Or if you want us to return earlier, we can agree. Sorry? 52. Oh, sweet. What's your answer? Huh? 0,038. Okay, 46. We are fine. Don't now give me the whole thing because I said you don't know. It's fine here now. 46. Okay. Moles. Is that fine with you? Step 1. What is step 2? Mole. But do you remember we are looking for that, right? So it's that and that. So it is Cr and what? Electrons. 1 ratio what? 3. 0,03846 to N. Can we cross multiply? We multiply that by 3, right? What are we going to get? 115? All right, 384. Thank you. Now, 6. Okay. Now, do we have our N already? We do. N equals to what? Q over what? QE. Do we know the number of moles? 0, what? 1153846. What is the charge on an electron? Okay, whether you say negative or what, it doesn't really matter. Negative 1,6 times 10 to the power negative what? 19. What's your Q? I'll tell you what the negative is going to tell us now. Yeah, we are multiplying by negative. Sorry? Negative 1,846. Okay. This is a 5, right? Times 10 to the power? Now, do you know what the negative tells you? It says that what? Check the question. Calculate the number of total charge transferred. We are transferring charge from here. It means we are losing. So what's the negative telling you? It's lost. So, but don't leave your answer like that. So what's my final answer? Q is what? 1,85 times 10 to the power negative 20 what? No. Columns. Quantity of charge. not electrons. Remember electrostatics. Q is measured in coulombs. You see, it follows my 3 steps of stoichiometry. Same thing. Make sense? So start by your reaction and then walk through. They will not give you number of moles. Always write the formula you want first. What is the formula? That's what we want, right? Do you see we need to get what? Number of moles. Then understand. Work from the other side. Number of moles, mole ratio. You get the number of moles required, and then you can calculate. This should be number of moles. All right. We take a break. You let me know. 15:30. Your choice. When we come back, what are we looking at? We're looking at, okay, there's one acid and base that was sent on the group. I have this. Multiple choice. I have a rate of reaction that I'm going to look at. And then we continue like that and see how many questions we can deal with. Let me know how many minutes are we taking.